This video is about periodic phenomena. This is AP Precalculus topic 3.1. If you appreciate this content, please give it a like. A periodic relationship between two variables occurs when the output values demonstrate a repeating pattern over successive equal-length intervals. The period of a periodic function is the length of the x values that it takes for the function to complete one cycle. Example 1. The function f is periodic with period 4. A portion of the graph of f is shown above. Draw two additional periods for the graph of f on the axes above. Here's one cycle of the function highlighted in blue. You can see the length of the cycle is the period of 4, and two cycles are showing. We just need to repeat two more cycles of the function. So here's f of x with 4 cycles, or 4 periods, shown. Example 2. A portion of the graph of the periodic function g is shown above. What is the least possible value for the period of g? The smallest repeating pattern is we see a horizontal segment followed by a v, and then it repeats, a horizontal segment followed by a v. The horizontal length of the smallest repeating portion of the function is 5, so that's the smallest possible period. Example 3. Using the function g and the period found in example 2, find the following values. Because the period is the change in input value that it takes for the function to repeat, adding or subtracting the period with any input value will give you the same output value. For example, g at 2 is 6. Now, if we take that 2 and add the period of 5, that gives us g at 7. And guess what? G at 7 is also 6. So again, adding the period to any input value gives you the same output value. So in general, if p is the period of a periodic function, then g at x plus or minus p will still equal g at x. In other words, adding or subtracting the period will not change the value of the function. In fact, we can generalize this further and say that g at x plus kp is equal to g at x, where k is an integer, because now we are adding multiples of the period. Obviously, if you add the period once, that doesn't change the value. So if you add the period again and again and again, that still won't change the value. So adding multiples of the period will not change the value. I have taken away the plus or minus because I'm saying that k is an integer. That means k itself could be positive or negative, so there's no need to write a plus or minus. A moment ago we observed that g at 2 is equal to 6. Then we saw that adding the period to this input value gave us the same output value of 6. Now I'm saying that if we take that input value of 2 and add any multiple of 5, including negative multiples, we will get 6 for the output value. For example, if I take that input value of 2 and I add 3 times the period, I'm going to get the same output value. So g at 17 will also equal 6. Let's do one more with a negative multiple. If I take that input value of 2 and I add negative 4 times 5, I should still get an output value of 6. So that's negative 2 minus 20, which is negative 18. So g at negative 18 will still equal 6. Getting back to example 3, part A, g at 14 is off the chart, but I can add or subtract multiples of the period without changing the output value. So let's subtract multiples of 5 from 14 until we get a value that's on the graph. Subtracting multiples of the period from the input value of 14 will not change the output value. So g at 14 will equal g at 14 minus 10. In other words, g at 14 will equal g at 4. Looking at the graph, g at 4 is 7. Therefore, g at 14 is 7. Part B, g at 72 will equal g at 72 minus any multiple of 5. Well, we know that any number that ends in 0 or 5 is a multiple of 5. So 70 is a multiple of 5. So g at 72 will equal g at 2. Looking at the graph, g at 2 is 6. Well, that was the example that we did. That means that g at 72 is also 6. Let's do the same thing for part C. Since we have a negative value that's off the chart to the left, let's add multiples of the period to get the same output value. Since the period is 5, we should be able to add any multiple of 5 without changing the output value. So we should be able to add 20, 4 times 5. So g at negative 17 will equal g at 3. And a quick glance at the graph tells us that g at 3 is 7. So g at negative 17 is also equal to 7. Example 4. The graph of h is periodic with a period of 5. Values of h are shown at selected values of x. Find the following values. Part A, h at negative 2. Since the period is 5, adding or subtracting 5 to negative 2 will give us the same output value. So, if I add 5 to negative 2, that's going to give me positive 3. So maybe just to show my work, this will be the same as h at negative 2 plus 5, which means that h at negative 2 will equal h at 3, and that's on the chart. So we can now say that h at negative 2 will equal 0. Part B, h at 6. Since the period is 5, adding or subtracting 5 with the 6 will not change the answer. So h at 6 will equal h at 6 minus 5. So h at 6 will equal h at 1. And h at 1 is right here on the chart. So therefore h at 6 will equal negative 2. Part C, h at 9. Since the period is 5, subtracting 5 from the input value will not change the output value. So 9 minus 5 is 4. So h at 9 is the same thing as h at 4. So this will become h at 4. H at 4 is on the chart. So h at 9 is equal to h at 3. But then h at 3 is also on the chart. So h at 9 is equal to 0. For part D, we need to find the value of h at 5k minus 3, where k is an integer. But since 5 is the period, 5k is a multiple of the period. Adding or subtracting a multiple of the period to an input value will not change the output value. So basically, it doesn't matter what k is, the output value will be the same. So we just need to pick a value of k that will cause the input to be something on the chart. For example, let's say k was equal to 1. That would mean we would have h at 5 times 1 minus 3. That would be 5 minus 3, which would be 2. But that's no good because 2 is not on the chart. But what about at k equals 2? Well, that would be 5 times 2, which is 10, minus 3, which is 7. So at k equals 2, we have h at 7. And h at 7 is 2. That means h at 5k minus 3 will equal 2 for any value of k where k is an integer. By the way, you need to know what the word integer means. This is the set of the integers. An integer can be a positive number, a negative number, or 0, but an integer cannot be a decimal or a fraction. It is useful to have a notation to model this phenomena. A periodic function starts with a basic pattern and translates the pattern repeatedly over its domain. As a result, we are able to consider a periodic function as a horizontal translation of itself. In example 4, the period of h was 5, meaning that we could translate the graph of h horizontally 5 units and end up with the same graph. This means that the function h satisfies the following equation for all values of x. H of x is equal to h of x minus 5. Also, h of x will be equal to h of x plus 5. In general, h of x equals h at x plus kp, where k is an integer and p is the period. This is a tidy way of expressing that adding integer multiples of the period to the input value will not change the output value. Example 5. The graph of f is periodic with a domain of all real numbers. 2 full periods of f are shown. Find all input values of f that yield an output value of 1. I've highlighted one period of f in blue. You can see that the period of f is 4. Next, let's identify one input value where the output value is 1. We see that f at 2 is 1 and f at 6 is 1. Let's just go with f at 2 is equal to 1. Adding or subtracting multiples of the period to the input value will not change the output value. So f at 2 plus, and we're going to do multiples of the period, so I'm going to say 4k is equal to 1. So all the input values that yield an output value of 1 are 2 plus 4k, where k is an integer. Make sure to include this last part. You must define k as being an integer. There will be 4 free response questions on your AP exam. Here's an example of what you might find on FRQ 3. The figure shows a large clock mounted to a vertical wall. The clock has an 8-inch long moving minute hand. The center of the clock is 120 inches directly above the floor. At time t equals 0 minutes, the minute hand is pointed directly up at the 12. However, the clock is not working properly, and the minute hand is moving twice as fast as it should. Thus, the next time the minute hand points directly up to the 12 is at t equals 30 minutes. As the minute hand moves, the distance between the endpoint of the minute hand and the floor periodically decreases and increases. The periodic function h models the distance in inches between the endpoint of the minute hand and the floor as a function of time t in minutes. Part A. The graph of h and its dashed midline for 2 full cycles is shown. 5 points, f, g, j, k, and p, are labeled on the graph. No scale is indicated, and no axes are presented. Determine possible coordinates t, h of t for the 5 points f, g, j, k, and p. We are told that the center of the clock is 120 inches directly above the floor, so that's going to be the height of the midline. We are also told that the clock has an 8-inch long minute hand. So, the endpoint of the minute hand will be 8 inches above the midline when the minute hand is pointing straight up. So that will be a height of 128. the endpoint of the minute hand will be 8 inches below the midline when the minute hand is pointing straight down. That will be a height of 112. We have now determined the output values of all 5 points. We just need to determine the input values. Height is the output value, so we put height on the vertical axis. Time is the input, so we will put times on the horizontal axis. We are told that at time t equals 0 minutes, the minute hand is pointed directly up at the 12. That means t equals 0 is going to correspond with one of these points where the height is at 128, the highest value. Let's call this point t equals 0. Normally, a clock takes 60 minutes to complete a cycle. So if the minute hand is pointing directly up at t equals 0, the next time it will be pointing directly up would be at t equals 60. However, this clock is not working properly, and the next time the minute hand points directly up is at t equals 30. So this will be 30 right here. We can figure out the remaining input values using common sense. Halfway between 0 and 30 is going to be 15, and half of that is going to be 7.5. So each one of these jumps is 7.5. Adding 7.5 to 15 gives us 22.5. Now that we have the input values and the output values for every point, we can list off the coordinates. So the point F is at 0, 128, and then point G is at 7.5, 120. Point J is at 15, 112. Point K is at 22.5, 120. And point P is at 30, 128. So that's it for Part A. Part B. Refer to the graph of H in Part A. The t-coordinate of G is t1, and the t-coordinate of J is t2. Part 1. On the interval from t1 to t2, which of the following is true about H? t1 is the input value of G, and t2 is the input value of J. So the interval from t1 to t2 is just the interval from G to J. On this interval, is H positive and increasing, positive and decreasing, negative and increasing, or negative and decreasing? H is clearly decreasing on this interval. We can see that it is falling from left to right. So the answer is either going to be B or D. Now, is it positive or negative? Well, look at these output values. They are all positive. So H is positive and decreasing, and the answer is B. B, Part 2. Describe how the rate of change of H is changing over the interval from t1 to t2. In Unit 1, we learned that h of x is concave up when the rate of change is increasing, and h of x is concave down wherever the rate of change is decreasing. Because h of x is concave up on the interval from t1 to t2, we know that the rate of change of h is increasing. They did not ask us to justify our answer, so we can simply say increasing. In fact, it's safer just to give a one-word answer here. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.